Gases in rock and coal. Gas in rock and coal. In most conventional reservoirs, the gases and petroleum liquids are transported from the source rock to the reservoir rock. In unconventional reservoirs, the petroleum fluids are generated within the reservoir rock. Not all gas is of a petroleum nature. It may be generated by igneous activity when it frequently contains carbon dioxide and nitrogen. It is also possible to have gases that are generated by the breakdown of water by radioactive sources. Gases may be a source of fuel or a hazard that lead to outbursts, ventilation problems, and explosions in mines or tunnels. Gas storage. Gas is frequently stored in pore space or fractures. Gas is stored by solution in liquids, typically oil or water. Gas may be absorbed into the rock, usually within carbonaceous material. The storage characteristic of this type of reservoir rock is described by the absorption isotherms. These describe the amount of gas stored in the rock over a range of pressures at a particular temperature. Measurement of gas within rocks. CIGRA measures the amount of gas within rock or coal by direct measurement processes, rather than by the use of petrophysical techniques. CIGRA uses three techniques. 1. Core desorption, which is useful for coals and carbonaceous, unconventional reservoir rocks. However, gas held in pore space is likely to be lost. 2. Core recovery with gas capture, which captures all the gas held within the rock and brings it to surface within the core barrel. And 3. Gas content while drilling. This technique is used with open-hole drilling. It can be used to capture and measure all gas in the rock being drilled. Core desorption. Core desorption requires collecting the core from wireline coring operations and placing it within canisters and measuring the desorption of the material over time. Here, a canister is being placed in CIGRA's core desorption trailer, where it is held at a constant temperature, and the gas desorption is measured automatically by positive displacement flow meters. There is always some lost gas during the core recovery, and this is calculated by studying the desorption characteristics. Residual gas is determined by crushing some of the core at atmospheric and lower partial pressures of the gas. Gas capture core barrel. CIGRA's gas capture core barrel is designed for use as part of the HQ core drilling system, which is frequently used in mining and coal seam gas exploration. It captures all gas released from the core during the wireline core retrieval to surface. This gas is stored within the core barrel and is measured when the core barrel reaches surface. The core is recovered and the residual gas it contains is measured by desorption and by crushing to complete this process. Gas content while drilling. What do you get out of an open hole drilled in overbalanced mode? What you put in equals drilling fluid. What you cut equals rock and contained fluids, nothing else. The fluids include gas. This is the basis for a precise measuring system. In this process, an open hole is drilled using a drilling fluid that is maintained at a higher pressure than the formation fluid pressure. Doing this prevents fluid leaving the formation and flowing into the hole. The hole is drilled and the material that is cut includes gas. The drilling fluid and this material is circulated up the hole annulus to the top of the hole, whereupon it is passed through a cyclonic separator that separates the gas from the drilling fluid for measurement. The drill cuttings are passed over a shaker and are collected for further desorption. The system captures virtually all gas that is released. The system is suitable for lower permeability conventional reservoirs and unconventional reservoirs. It may be used for exploration or be fitted to production drilling operations to determine the gas content during production drilling. This plot shows the gas released from a coal seam during drilling versus the carbonaceous material content derived from a density log. The gas content from this process is considered to be more precisely measured than that from core desorption. The process is particularly cost-effective for use in thicker, unconventional gas reservoirs or multiple coal seams. CIGRA measures the relationship between pressure and gas content of rock by its laboratory and native isotherm procedures. Laboratory isotherms are measured using one gas type at a time, but have to be theoretically combined for mixed gas cases. Native isotherms are derived from the initial desorption of core directly following its recovery to surface. The use of native isotherms avoids the problems with the theoretical issues with recombining laboratory isotherms of different gases at uncertain moisture contents. Because there is lost gas before a laboratory isotherm test commences, it is useful to have laboratory isotherms to assess the gas held at higher pressures. The plot shows Langmuir isotherm fits to experimental data. The sorption measurement equipment in the laboratory. CIGRA also measures the dimensional change brought about by degassing carbonaceous rocks, as this alters the effective stress within them and their permeability. CIGRA has developed stress path analysis for coals. Stress path analysis is used to predict the changing effective stress that occurs through the production or drainage cycle. It is derived from a combination of measurements of fluid pressure, coal stiffness, and shrinkage as the coal gives up gas. It assists in determining the changing permeability of coal as gas and water is withdrawn.